Here we have on z plus, or the set of positive integers, let star be defined as a star b equals c, where c is the smallest integer greater than both a and b. We are going to determine whether this operation star is a binary operation or not. To do that, we simply need to establish the idea of the closure property. Closure property tells us that if we are going to pick any two elements on our set z plus and subject to this operation, the resulting c should already be an element of z plus. If we could find other elements outside z plus, which is the result of a star b, then closure property will not hold, and the operation is not a binary operation. Of course, z plus, we can have here 1, 2, 3, ... because we have infinitely many elements here. And we are trying to determine the presence of c as a result of a star b, where c is again is the smallest integer greater than both a and b. From the operation itself, we have here integer. So we are sure that c is an integer, right? Because we are sure that c is the smallest integer greater than both a and b. What we just need to establish is that these integers, c, should be positive, so it would be element of z plus. Of course, if we're going to pick 1, star 2, the result here is c, wherein is the smallest integer greater than both a and b. So we have here 3, because a 3 is greater than 1, and 3 is greater than 2. And 3 is an element of z plus. Okay, our goal here is to show that all elements would fall under the same set z. Of course, what we don't want is a negative integer. Even if we are sure that c is the smallest integer, what we don't want is a negative integer or even 0, because it will not fall on z plus, hence we are not going to have closure property here. If we're going to have 1, star 1, 1 and 1, the smallest integer greater than both of this is 2, and is still element of z plus. We can only say that the closure property will not hold if we are going to get c which is 0, right? Because if c is 0, that would mean it will not fall on z plus, and closure property will not hold. But when would we get c equal to 0? That is if c is greater than both a and b. That would mean we can only get that if a is negative 1 and b is negative 1, right? Because if we have here negative 1, star negative 1, the next or the smallest integer greater than negative 1 is 0. If we have this situation, that we can say the closure property will not hold and that the operation is not binary. However, in the first place, a is not an element of z plus. B is not an element of z plus. We can only get 0 if we are going to use elements which are in the first place not an element of z plus. What does it tell us? This would mean we can never get 0 if we're going to stick with the definition there, because we will not be using negative 1 to get 0. And we will not, in short, we will not be getting 0 if we are not going to use negative 1. That's what it means. In short, we can never get an element which is not an element of z plus if we are going to use all elements of z plus itself. This would mean that our star here is a binary operation, since the closure property holds for z plus using the same definition of star. So this is how it goes for this given example. Thank you very much for watching.